Okay, so yesterday we did LRAM and we did RRAM. So we got an overestimate of underestimate. We're also going to do MRAM on this same one. But we're not going to do a whole nother drawing. We're just going to draw a midline on this one. We're going to go up to the middle and draw boxes on each one, just in a different color. Okay, so we're going to do MRAM. We're going to do still the same number of rectangles, so they're still going to all be 0.4 wide. Okay, so how many we had? N was 5. So the area would be 0.4, and the heights are going to be what the heights are in the middle of each one of these boxes. So if you're halfway between 1 and 1.4, where are you? 1.2. So we're going to go up from 1.2 until we hit the line. And you can use a different color. You don't have to use a different color. I have different colors back there, like there's markers and colored pencils and whatnot, and boxes back there if you want them. Okay, so you would draw it how high you are at the midpoint. So the box, it's not 2 boxes, it's one big box. Okay, so this is the rectangle. It's just that high. Okay, so when I say how high is it, what would I call that? F of what? You got it. And then my next one is going to be in the middle between 1.4 and 1.8. So I'll go up at 1.6 until I hit the line. And that's how tall that one would be. Okay, so it's the same rectangle. It just stops at the red line. So that would be F of what? Yeah, that's it, 1.6. The next one's going to be F of what? 2. So I'll go up at 2. By the way, shout out for Frances. I heard she ran the Mu Alpha Theta meeting. Good job.
Did you guys decide to give people who didn't turn in their hours semester, last semester, second semester? Yeah. Thank you, Francis.
But they have to do an extra hour. So you have to make up for it, do this times, and an extra hour in the Learning Center.
So okay, 2 hours for the rest?
Yeah, but a total of however many, what is it, 3 hours each?
So,
See.
like, if last semester you only did 2 hours, next semester, or this semester you have to do your 3 for this semester, plus an extra one in the Learning Center, plus the one you made up.
Yep.
Or you missed.
Okay, wait, so
however many you missed from last semester, plus an extra one.
how many hours do we have to do outside of school?
Well,
You have to do a total of 3 hours each semester.
and one has to
Yeah,
be
one in the
So
Learning Center,
now
2
you'll have to
hours.
do a total of 7 hours
6
between the two. No.
Because I did
David,
one
how
in the
many-
I'm total. Total.
David, how many did you have last semester?
1.
So this semester you have to do the 3 for this semester, plus the 2 you missed, plus an extra.
6.
You have a
Six
punishment.
this semester.
Except it's not a punishment because tutoring kids is
That's right. All right. So the next one's going to be how high? Hello? How high is the next rectangle? Which is it? That's what we wanted. F of 2.4. All right. We gave the missing kids some random Mu Alpha Theta banter for free that they couldn't hear. And the last one, how high is it? Okay, and so we should be able to go even to what might still be up there from yesterday. Calculator's having a hard time waking up. Nope, not still there. Okay, so I'm going to go and put my equation, which was x squared, right? And for me, that's F6. So when I go to this, I'm going to do, to the calculator page, I'm going to do 0.4 parentheses. My variable will be F6, and I'll put in each of those, 1.2 plus 1.6 plus 2 plus f of 2.4 plus f of 3. Is that right? No, I'm off. What am I doing? 2.8. I was going up by. Thank you. Okay, so you get 8.64, which you'll notice is pretty nice in between the two values that we got before. Okay. All right, so we have RRAM was 10.32, MRAM was 8.64. Does anybody remember what LRAM was?
7.12. The average RRAM to LRAM is 8.72.
Okay. Now, here's how you find the exact. If I can spell exact. You just integrate from 1 to 3 of x squared. Okay, so what do you get when you integrate x squared? Okay, remember you add 1 to the exponent and then times the reciprocal of the new exponent. Instead of doing plus c, if you have bounds, what you do is you substitute in the upper bound minus substituting in the lower bound. So it would be 1/3 times 3 cubed minus 1/3 times 1 cubed. So you would have 27 thirds minus 1/3, 26 thirds. 3 goes into 26 8 times with 2 left over. So the exact area is 8 2/3. So 8.64 was already getting pretty close. So pretty good. All right.
Why do we not just always use the MRAM if it's like the most precise?
I mean, no reason why not to. I will show you a tiny reason why not to when you're trying to take the limit as n approaches infinity. The algebra is easiest if you do the right endpoint versus the middle, because you're having to get that average in the middle. So the algebra is slightly easier. If you're doing it numerically, I agree with you. It seems to me MRAM goes a lot faster, so why do the others? Okay. All right. Now, when you turn over, okay, what I'm trying to show you here is basically what happens as you go towards infinity, in general, without actually doing it. Now, I'm going to actually show you one problem, taking the number of rectangles and then letting the number of rectangles go to infinity. Not today, okay, but next class. Okay, so the one that we did, we could use summation notation to write this area that we've been doing for LRAM, for RRAM, for MRAM. This is summation. We're summing from 1 to 5 because we did 5 rectangles. What does the f of xi represent? Well, it tells you. Right. And the delta x was the same for all of them, right? Okay, that was the width. Okay, so when you write it in that notation, what you're saying is you're doing f of the first height times the delta x plus f of the second endpoint times delta x plus, okay, so this means you put in 1 for the I, then 2, then 3, then 4, then 5. Now I didn't do that for the delta x because for ours we used the same delta x for every single one. Okay, and you don't have to write all this out. I'm just showing you what that means. Okay, and technically that would mean delta x1, delta x2, delta x3, delta x4, delta x5, but for us we used equal widths for all of them. Okay, and so the true area lies between the overestimate and the underestimate. Okay, so if you look, this is the limit as the number of rectangles approaches infinity. So if you look and just do this, okay, if in general I didn't say I had 5 rectangles, I just said I have a formula for n rectangles. And you can make a general formula that tells you the area for however many rectangles you have. Like you put in N is 27, it'll tell you the area based on 27 rectangles. You put in 85, it'll tell you the area based on 85 rectangles. So you can make a general formula. And so you do the summation from 1 to n of just the heights times the widths. If you take the limit as n approaches infinity of that, that's the same as finding the integral. They are identical. Okay? And when you look at this notation, what they're doing is this summation, the notation kind of matches, turns into an integral. An integral is adding them all up from a to b, which is your left endpoint and your right endpoint. The f of x, that is representing your height. The dx is representing the width of each rectangle, and it's infinitesimally thin. Because if you're making your number of rectangles go to infinity, then your rectangles are getting more and more narrow. Okay, so this dx is representing for you the same as the delta x. Okay, what this little guy right here is saying is that you can do a lower Riemann sum and an upper Riemann sum. Now, a Riemann sum just means that it doesn't matter the width of the rectangles. Okay, so we did it where they were all the same width. You can do them where some are skinny and some are wider. Okay, so if you do the lower Riemann sum, if you look at lower, then what you see is for this particular one from A to B, they picked the lowest it was on that interval, the lowest that this rectangle could be on this interval, the lowest this rectangle could be, all the way through they picked the lowest. This is an upper sum. For each interval, they picked the highest it could be. So that could be left, right, or in the middle. So an upper sum is picking the tallest spot it is in any given interval. Lower is picking the lowest. Now, it actually doesn't matter. If you let the number of rectangles go to infinity, it doesn't matter if you picked the lower or the upper or somewhere in between. Because the more rectangles you do, the closer your area is going to be, regardless of whether you pick left, right, or in the middle. Okay, so the true area lies between the upper bound and the lower bound. Okay, and it gets squeezed basically in between, the closer your accuracy is to the exact value. So this is the Riemann sum, and it's how we form our definition of a definite integral. So if you look, this little guy right here, the summation from 1 to n of f of xi times delta xi. Okay, what they're saying here is you're just going to add up the rectangles, the height times the width, and it's a Riemann sum if you don't care where you pick the height. You don't care if it's left, right, or middle. Okay, and so if you do that and you let the number of rectangles go to infinity, then that's the same as the integral from a to b of f of x dx. That's the definition of it. Thoughts? The little asterisk, all they're saying is if you do x, see how it says arbitrary point? So it says in subintervals where the ith subinterval has an arbitrary point. So it's how they define an arbitrary point. So like if you look on this from here to here, they did a lower sum, but they're saying it doesn't matter. Choose any point between here. So I could have picked here. Okay, so on your interval, they don't care where you pick on there. Okay, so the xi just represents the height at some point in the interval. They don't care if it's left, right, or in the middle, or 3/4 of the way, or whatever. So that's what they're meaning by that xi asterisk. Okay, all right, now here's the thing. Last night, hopefully you did this. I don't know if you did or not. I'm hoping you did. You drew a picture of the square root of x from 1 to 4 using 4 rectangles of equal width and did a lower sum and an upper sum approximation. Now, I'm not done by any means, but this is now added to it. Now, when it says ebook, that means that it's not in your hard copy book. So everything that's in the option part of calculus is not in your regular HL book. You have to go to the online version. So, no, integrals aren't, but Riemann sums are. So the thing is, we're calculus option, but some of the little option sections make more sense while you're teaching the core, like they fit in better. And then there's some stuff that's just above and beyond the core part of calculus. So calculus is both in the core and in the option. Yeah. So you take 3 papers. What is it? HL Rocks? Usually it just shows up for me.
I tried every single number pretty much except for one, and that was hard.
Well, 1 works. And it'll tell you, welcome, Kathy McCormick. You'll be happy.
I've like tried 2 through 10, and like I tried my section, which was like 7.
Okay, well, you absolutely have to get to the online book. It's not in your regular book, so I'm just kind of showing you. If you know the page, you can just put it in right here, which makes it easy. But if you go down here to where it says options and click this little guy, you'll see these are the options, 7, 8, 9, and 10. So they don't print those, but the only option you'll ever do is the calculus option. So if you click on that, it gives you the calculus option. I also have that under year-long resources as a PDF in ManageBack, so you can go to that. You don't. So if you didn't have, if you couldn't log onto this, you could get there. But if you just go 1436, it takes you to the page that I'm talking about, and you're doing 18 through 28A and B. So I'm just going to kind of show you that. Where's the thing that makes it bigger? Go away. There we go. Okay, so if you look at these two, they're asking you to do upper and lower, they're asking you to do Riemann sums. This one's asking you to do a right interval. So this means I need a sketch. So 18 needs a sketch and 19 needs a sketch. Okay, when you get to 20, I'm going to go ahead and tell you about how to do that now, because I always get asked, and it's actually super easy. So this says, in questions 20 through 22, express the limit as a definite integral on the given interval where xi is an arbitrary point in the ith subinterval and delta xi is the width of the ith subinterval. Okay, that's a lot of words. But basically, if you're taking the limit as n approaches infinity of a summation, that means you're taking an integral. Pretend that's an integral sign. You're doing it from 0 to 4. These are your bounds. Your function is this. So it would be the square root of x plus 6. Sadness. The delta x, that doesn't even look like a plus, does it? The delta x is your dx. That's all they want you to do on that problem. So they're not asking you to integrate it. They're asking you to understand that if you take the limit as n approaches infinity of adding up the triangles, this is f of putting in the x times delta x, that it's the same as the integral. So I just worked number 20. That's the answer. You're done. You don't have to do the work. You just literally have to write that. Now, I will tell you the disadvantage of anything that's in the option is they do not have the worked solutions. They do have the answers, but the answers are wrong half the time. Okay, so you can check it. Oh, I'm wrong. Well, I might be right. Okay, because they're just not consistent, whereas the worked solutions are right, and they explain it to you. And where you find the answers are at the end of the entire option. So if you scroll to the very end, it just has a list of answers. So that's easier to do in the PDF than it is here, because I just have to keep advancing until I got to the end. But that's how you do that. And then there was a couple more on the next page. Okay, so this is, again, just all you got to do is write it. And then it says 23, A and B omit C. The reason you're omitting C is I haven't taught you how to integrate it yet. Plus, it's got 8 rectangles. That would be a pain to draw. Okay, so first it says estimate the definite integral, 3 sig figs, by finding the value of the Riemann sum with n subintervals. Use the midpoint as the arbitrary point. So you're doing MRAM on this one with 4 rectangles. Okay, then this one tells you to do, just find it. Just integrate it, put in the upper curve minus the lower bound, the lower curve. And then here, just say if you were an overestimate or an underestimate and find the percentage error. How do you find percent error? Okay, so which is the right one? Okay, so percentage error, you do the difference between these two over this one, because this is exact. Okay, so generally speaking, when you do error, you normally do, this is the actual, and then let's see if I'm going to get it right. Experiment, if it was too high, experimental minus actual. And then if you do times 100, that'll give you a percent. Okay?
So, on number 23, I'm doing I through just those two. But do those apply to A and B?
Yes. Sorry. So 1, 2, and 3 apply to A and B. You are not doing this one because I haven't taught you how to integrate that by hand. Okay. All right. So that's the homework. Yes. Yes. And so the way that the IB exam works is you have paper 1 and paper 2, and paper 1 and paper 2 are on the core, which means everything from pre-cal to next year, okay, is the core. And then the option is paper 3. And by option, all it means is the teacher chooses the option in which we instruct you. And so in some subjects, I think it might be that y'all can pick which questions you want to do. For me, it's not. I picked it. I picked the calculus option. Your paper 3 will be just a calculus option. And so you will answer all of those questions. You will never be choosing which questions to answer. You will always be answering all of the questions in front of you. All right, so back to the program. So now what we're going to do is just some of the integrals that we can find using like regular shapes. So you'll like the rest of today. It's easy. One day will be a little tough. And then like all the days after that will be a little tough. But today's good. Okay. All right. So we already said we don't need calculus if it makes a basic shape. So we're going to basically use basic shapes to do calculus. If that makes any sense. It will in a minute. All right, so if it wants me to find the integral from 1 to 3 of 4, what I'm going to do is graph. This is your f of x. Okay, this is basically just representing infinitely thin rectangles. Okay, but I'm just going to graph y equals 4. What does y equals 4 look like? There you go. So I'm going to graph that. Boy, that was tough. And I want the area under the curve from an x value of 1 to an x value of 3. So this dx is also telling you your x bounds. If that was dy, it would be telling you y bounds. And yes, that actually happens. Okay. Yes. I had to think for a minute. That always happens with Jake. Y'all ever notice that? All right, so we're finding the area under the curve from 1 to 3.
That's a good thing.
Yes, it is a very good thing. That's what I tell him now. That's what I tell him later. It's just the way it is. All right, so you're finding the area under the curve y equals 4 from 1 to 3, and you're like, I don't need calculus. I knew how to do that when I was in 6th grade. Okay, so you just find the area of a rectangle. What's the, I don't know, base and height? Okay, so this is 2, and this is 4, so I agree. So this is just 4 times 2. The answer is 8. Now it's also important to understand that if your curve is above the x-axis, then the integral will be positive. If your curve is below the x-axis, your integral will be negative. Now area is always positive. Okay, but I will do some that are above and below, but anything above, the integral answer will be positive. If you have a mixture of positive and negative, you just got to see which one's more powerful. Do positive for the part above, negative for the part below. See what the difference is. Okay, so I'm going to graph x plus 2. That has a y-intercept of 2 and a slope of 1. Y'all sound so excited. Up 1 over 1 for a couple of times. I only need to go 0 to 3. So I'm going to shade under the curve from 0 to 3. Looks like a trapezoid. What's the formula for the area of a trapezoid? There you go. Now, if you forgot that, it is on your formula sheet. I'm pretty sure it says formula of a trapezium on your formula sheet under prior knowledge. I don't know. So then you could also, if you did a triangle and a rectangle and added those together, that would also be fine. Any way that you can figure it out. Now it's important that you know that the bases are parallel to each other. So for this particular problem, if I'm looking at bases, this one and this one are not parallel. Okay, it's this one and this one are parallel. So that means these are my bases. Doesn't matter which is which. And then my height has to be the perpendicular distance between those, which is that guy. Okay. And so, what is my height? 3, from here to here. And then either bases that you want to give me? Is it 6? 2, 3, 4, 5. 5. Okay. All right, so we've got 3 halves times 7, so 21 halves. So this integral is 21 halves. All right, what do you think about this guy? You know how to graph it without your calculator. Should be, it is a shape, you know.
It's like, well, the square root of x, like we did in homework last night.
Was a yeah, that's true. Okay, so you're giving me a couple of the points. So you're telling me at 2 it's okay. At 1 it's not 3.
Oh, it's
Square root of 3. Okay, so like 1.7.
0.
At 0 it's what? 2. It's alright. You're not, in fact, dying. It's not a triangle. Okay, I'm going to take this and I'm going to square both sides. See if I can give y'all some hints here. So I get y squared. What happens on this side when I square it? Now I'm going to add the x squared over. Do you know what that's an equation of? That is a circle. Okay, so if you remember, this is the formula for a circle, and the HK is center. Well, yeah, it'll be the origin for me because I don't have anything, and then the radius is just R. Okay, so for me, this is a center 0, 0, and it is a radius of 2, because that's R squared right there. So you take the square root. Now, but it's not the whole circle. It's just half the circle. Which half do you think it is? It is the top half. Okay, and you can figure that out if you take this and solve it again. So if I take this and solve for y squared, you'd have y squared is 4 minus x squared, and then take the square root, you'd have 2 answers. And so the positive one is the top half of the circle, and the negative one would be the bottom half of the circle. So I can give you either one, but this time I've given you the top. So it's just center 0, 0. You'd have a radius of 2. It does go through the points that you guys already gave me.
So why is it not the bottom half as well? Because that's what we assume the square root.
But this was the original. It already had the square root.
Yeah, whenever we take a square root, don't we assume that there's 2 answers?
Right, but you see, this is only half of that answer. So the thing is, when you square both sides, you can get an extraneous answer, which is what happened. So if you started with this, it's the up and the down. But when you do this, and you solve for y, it gives you 2 answers, one of which is yours. Yours is just the positive part. If it had the negative, it would be the negative. So it breaks it into 2 different ones, and yours is only that one.
Yeah, I always assume that there's a square root, there's a plus or minus.
There is, but that's if we started that. But this does not assume the plus or minus. It's telling you, I just want the plus one. I promise. Okay, so we want this area. And that's a common shape that we know. All right, I like it. Half a circle. So a half pi, what's my radius?
2.
So this integral is just 2 pi. Okay, and then I'm going to graph x minus 1. Tell me how to do it. Tell me how to graph x minus 1.
It's down one.
Okay, down 1. And then 2. Okay, so up 1 over 1. Up 1 over 1. Up 1 over 1. What's different about this one? Make the dots bigger, if I teach you anything.
Move it to the right.
That's true. What's different about the integral? There's some positive and there's some negative. Now, all area is considered positive, but when you integrate, any area that's below the x-axis is considered negative, and any area that's above the x-axis is positive. Okay, so there's still two triangles. So this guy, yeah. So this guy, what's the base and the height? 1, 1. So this guy's a half. What about this guy? 2 and 2. So just 2. So when you find this, the integral from 0 to 1 is considered to be negative 1/2. So it would be negative 1/2, and then the integral from 1 to 3 is considered to be positive 2. So if you go all the way from 0 to 3, it's 1 1/2 or 3/2. Okay, so the area is still positive, but the integral, if it's below the x-axis, is negative.
So the integral is 3/2, but the area is 5/2.
Yes, and that's going to matter when we're graphing velocity. So when we're graphing velocity, oh, I just got to tell you, just say this was v of t. Well, when you integrate from a to b of velocity, it gives you displacement. Okay. And so the displacement for this is 3/2. But if you want to know how far you traveled, so this is displacement. If you want to know distance traveled, you do the absolute value of it, which would be what you said, 1/2 plus 2 would be the 5/2. So when you do it as far as representing physical things, if this was velocity, this would mean you were traveling backwards and then you were traveling forwards. So if you went backwards for 1/2 a mile or whatever, and then forwards for 2 miles, your net is you went forward 3/2 of a mile. But if you want to know how far you traveled, you include what you did backwards and what you did forwards. And so you do the absolute value and you get the 5/2. So it has a physical interpretation too. Right. Couple of properties. Did we just like let all the troublemakers go on field trips because y'all are kind of quiet and regular? It's Rachel? Oh, Max. Oh. Okay. Okay, here we go. We'll shout out for you, Max. All right. The integral from a to a of f of x dx is 0. Okay? If you think about this, if I ask you to find the area under the curve from 5 to, doesn't matter what the function is, dx, sorry, I forgot my dx, it's nothing. You haven't traveled anywhere. So, like, even on the ones that we did, if I said go from 0 to 0, how far did you go? You have an infinitely thin line. You need like a length, a base, and a height. Okay? So if you don't travel anywhere, then your integral is going to be 0. The other one is if you switch the order of the bounds, it switches the sign on your answer. Okay? So if I know the integral from, let's take the one that I did over here, if the integral from 0 to 3 of x plus 2 is 21/2, if I travel backwards, it's going to be negative 21/2. So if I ask you what's the integral from 3 to 0, this is your start, this is your end when you read it. But when you substitute in after you integrate, you do the upper bound minus the lower bound. But from 3 to 0, you would just say negative 21/2. It's just the opposite. Okay, so if you switch the bounds, it changes the sign on your answer. All right, so those are two properties you need to know. All right, so for this guy, it says evaluate the integral from 4 to 2 of x cubed dx using the value, the integral from 2 to 4 of x cubed is 60. So they're telling you this is true, and they want to know what this is. What is it? You got it, negative 60. They switch the bounds, so you just do the sign as the opposite. Okay, this one looks fancy. Like, go show the little babies in 6th grade. I'm doing something fancy. The integral from pi to pi of sine x dx, what is it? 0. Okay. Another property that you need to know. See, this page looked like daunting, but it's nothing. It's very simple. Just a few principles. Okay, this is the additive interval property. It says if you're integrating from a to b of f of x dx, they're assuming that c is in the middle between a and b. Now this bothers some people because in fact in the alphabet, c is not in between a and b. I understand this. Okay, it's not that I don't know my ABCs. It does, but that's not how they did it. Okay, so they gave you a, c, b. So they gave you, if you do the integral from a to b, what they're saying is you can divide it up. Okay, the integral from a to b, if c is in between, you can add up the integral from a to c first. Okay, you can find out what a to c is, and then add on from c to b. Okay, so you can do it in little pieces. And that's what that guy says. Okay, so they want me to use that to figure out this last example on here. By last, I don't mean very last. Okay. This tells me the integral from negative 4 to 3 of a function is 6. The integral from 3 to 5 of a function is 2. And they want to know what would it be from negative 4 to 5. What do you think it is? Yes, it is in fact 8. So if you want to think about it in terms of this picture, it would be like they were saying this was negative 4, and this was 3, and this was 5. So they're saying if this is f of x, if the integral from negative 4 to 3 is 6, and then from 3 to 5 is 2, then if you're going from negative 4 all the way to 5, you just add them up. And you just get 8. Does that make sense? Yes, no, maybe? Okay, I've got a nod from Stella. It must be good. All right. So this guy says the integral from negative 1 to 1 of the absolute value of x. I can do this with simple shapes too. What does the absolute value of x look like? It does look like a v. And I don't even have to go very far. Like 0, 0, the absolute value of 1 is 1, the absolute value of negative 1 is 1, so it looks like this. Okay. So basically, I can find the integral from negative 1 to 0, and then I can add on the integral from 0 to 1. Okay, what's the integral from negative 1 to 0? It is, in fact, 1/2. A half, 1 times 1, so this guy's a half. The other guy kind of looks the same size. What do you think? Yep. So this is just 1. No, you're good. This is just the area of a triangle, so it's a half base times the height, and this was 1 by 1. Okay. These properties I already showed you. Okay. Remember when we did the PowerPoint with the fun party games? Yeah, okay. We said if there was a constant, we could just take it out. We said if we had the integral of 2 different functions multiplied, we could do the integral of one function plus the integral of the other function. Same thing if it's minus. Okay, so they want me to use those principles to figure this out. So this is the integral from 2 to 4 of 10 minus 3x minus x cubed, and they told me the value of some of these integrals separately. Okay, so what I'm going to do is do these, separate them. 2 to 4 of 10 minus the integral from 2 to 4 of 3x minus the integral from 2 to 4 of x cubed, which is running off the page. You know, I kind of like teaching from over here. I can see it whether what's on the board is working, but I can still see you. Very interesting. No, it's to a class. I just like to randomly stare at you for no reason, just to freak you out.
For us, you like to make class.
I know, I'm usually over here. Does this not look familiar to you? Over there. Okay.
Why don't you just do it from there?
I think I might. And then when I have to go over to the computer, it's not as far away. But if I want to draw on the board, that's farther. And I'm also out of the way, like, did you know I rearranged the whole room because people couldn't see over here because I was standing right there? Probably could have just moved this over here. I don't know. It's all good. Okay, once I do this, they didn't tell me the integral from 2 to 4 of 10. They told me the integral from 2 to 4 dx. Well, that's really like having a 1 there. Okay, it looks kind of empty with just a dx. Kind of makes me sad. Okay, but you could take the 10 out of this, and then that's just dx, or 1 dx. And then you can take the 3 out of this guy. And this guy doesn't have a constant to take out. Okay, so then you can just substitute in the values they gave you. So this would be 10 times the integral from 2 to 4 they gave me. It was just 2, so I'm going to put it in right there. And then minus 3 times they gave me this. It was 6. And then minus 60. 20 minus 18 minus 60. So 2 minus 60, negative 58. Okay. And now we're going to do a little guy on the calculus of motion. Negative 58. All right, so here we have a function. They didn't give me what the function was. If they were going to give me the function, they'd have to define it as a piecewise function. And Jake, that reminds me, you were asking me how to limit the domain on something you wanted to graph. You just have to do it as a piecewise. I forgot that's the difference. So on the 81, it actually lets you put in the function, and it lets you do something like parentheses, like 2 to 5 or something like that. Oh, okay. But I was like, why didn't I just tell them to do it as a piecewise and put it in different...
Trying to find the derivative of half a circle, and it's
Oh.
one word.
Oh, okay.
It was a relation instead of a function.
Ah, that's right. Okay.
So,
Was it the right half of the... Was the upper half of the circle or the right half?
Circle, and since it was still like a y squared plus x squared equals whatever, then
Okay.
it still wouldn't like do it.
But if you'd just taken the square root and done the upper half, it should have. Could have given it to you separately.
That's what I tried, and it still
Oh.
wouldn't work.
Okay, I don't know. All right.
I've even Googled like what's the derivative of the circle, and I can't find it anywhere on the internet, and it's killing me.
Oh, we can do it.
Have you looked up Google Scholar?
I was gonna make it my article, but I couldn't find anything.
Oh, yeah.
I'm pretty sure we're going to find it for you at some point.
Alright, let's do it.
Okay.
Instead
Alright.
of doing an article, can I just find the derivative of the circle?
No, it's not hard enough.
It's apparently it's really hard to know time.
No, they have.
Oh, look, this is the formula. We'll do it right now.
And then-
Here's
In a
the-
minute. All right. So here we go. So we have this weird shape. They didn't give it to us in equation, but it's all going to be simple geometric shapes. So if they ask you to integrate, for example, from A to B, then if you look at this from A to B, what shape is it? And what's the area? 6. But what is the integral from A to B going to be? Negative 6. So see, it's adding it up as it goes. So you got a negative 6. Because you don't have any pi, and it's getting ready for when you do have pi. And you have a circle. So 0 pi. All right. Now what about from B to C?
It's different.
2 different triangles.
It's like a little bundle.
They it will even out to be 0. So you could do a half the base times height of this. It'd be half like 2 by 2.5. Okay? But then you'd be doing the same thing here. A half, 2 by 2.5. This one would have a negative answer. This one would have a positive. So when it's adding up now, okay, so the negative, now it's becoming less negative because you're adding some positive value as you go. Thoughts from C to D?
R is 2.
We could like make it into a semicircle and a rectangle.
Okay, I agree with that. Sam, you could do it. Okay, so I was told this part would be 8. Try
Yeah,
Sam.
that was a really straight line you just drew. That was incredible.
Wait a second. If you draw it,
I thought you were mad at them.
What about this part?
That's 1, 2. 1 half.
Area of a circle is like pi squared.
What's R?
And the R is 2, so 1/2 is 2 pi.
So we should get for an answer.
8 plus 2.
All right, let's see if that's right. Get rid of this.
It is magic.
Do you believe in magic?
if somebody just draws a straight line like that,
Oh! I'm so sorry.
Yep.
Okay, looks like we got it. Okay, what do you think from D to E? Trapezoid, okay, what do you think?
The height is 2 and the bases are 1 and 2, so
I'm not even going to do it in, I'm not even going to.
2 times
1 half
3
of
times
3
1
times 2.
Could we make it
So 3.
trapezoid, a rectangle?
Okay. All right, so D, you can, but sorry, Francis already solved it. Okay, so 3. Okay, now,
8 minus 6 plus 2.
my next question is, if I go from E to D, what's the integral from E to D?
Negative.
oh,
What about from D to C?
negative 8 plus 3.
Minus 2 plus 2.
Negatives on both of them, right? What about from C to B?
0. Actually,
Oh, it
negative.
leads C to B.
Negative 0. What is negative 0?
Negative 0.
Okay, what about B to A?
Positive.
Positive 6.
There you go.
David, it was already negative.
David was such a fool. David was
Okay, we're not picking on David. Well, we are, but we're going to try not to. Okay. All right, one more thing I need to show you. This, you're basically, besides the homework I already gave you, you're just going to do a worksheet that you'll probably finish while you're here. Okay, because it's a good thing to work together with. But this is just to prep you for the worksheet, actually. Okay, it kind of does all the things you need. Here, if I can make it small enough. Okay, so I've given you a picture. I didn't have to give you a picture. I could have given you that equation because it's a line. We can figure that out pretty easily. But we're going to try to find all of these areas. Okay, so, well, integrals, but we're going to find them using areas. So this guy says to find from 0 to 2. So it wants me to find from here to here. Okay, the area under the curve. So that's this triangle right here. And I'm just going to make it look sad and outline it. Okay, so this area would be a half. What by what? Does it bother you how exaggerated these... Yeah, Tim's out. He's like, no. You do not have equal intervals on your x and y axis. It's true. It's kind of ugly looking. Okay. So the answer to this is 2. Okay. Now the next one's asking me to find the integral from 0 to 3. So I also need to add on this part. I've got from 0 to 2. I need to add on from 2 to 3. So what is the area of this guy? A half. What by what? 1 by 1. So that's just a half. So the area is a half, but the integral from 2 to 3 is what?
Negative.
Yes, because it's below the x-axis. So if I want to add it up from 0 to 3, then I would just have 2 plus a negative half. Okay. The next part is the integral from 0 to 3 of the absolute value of f of x. So you kind of have two ways to look at it. One is you could graph, and you're not going to want to do this on like your real one because it's a much, on your worksheet it's going to be much more complicated than this particular line. But if I was graphing the absolute value of this, what do you do when you do absolute value? Like, how do you figure it out? That does not show up. How do you find the absolute value of something? Yep, find y, make it positive. So these are all already positive. These answers are negative, so if I was graphing the absolute value of f of x, that's what it looks like. But on the particular thing that I give you, you're not going to want to redraw what the absolute value of f of x is. What you're going to do, if I give you an absolute value of f of x, is you're going to take any area that's above the x-axis, okay, and it's still going to be positive. But then anything, any spot, any area of it that's negative, it becomes positive because it would just flip up. So this would be a positive half. And you don't have to draw it to know that. Okay? You just, each section that was negative, you would just make it positive. Does that make sense? Okay. Now, 3 times f of x, I could draw 3 times f of x. I'd have to make all of these y values 3 times as high. I don't want to do that. Okay? Instead of being up 2, it'd be up 6. Ooh. Okay? But we know we can take out a 3. That seems a little easier. And we also found the integral from 0 to 3 already. It was 3 halves. So that, you got it. So that guy's just 9 halves. Oops, my pen's running out. Okay, and then this one is asking me the integral from 3 to 0 of f of x. What is it? It is negative 3 halves. Okay, because I already had from 0 to 3 was 3 halves. If you change the bounds, it just changes the signs. Okay, the last one. If I had f of x, and I wanted to find f of x plus 2, what would I need to do to everything? Everything up 2, right? All the y values up 2. So I could redraw this whole thing. Do you think I'm going to?
I don't think you
I'm not. So what I'm going to do is I'm going to separate it. Okay? I'm going to do the integral from 0 to 3 of f of x plus the integral from 0 to 3 of 2. I already found the integral from 0 to 3 of f of x. Okay? It was 3 halves. Now this one, you have a choice. You could draw a flat line at 2 and find the area under the curve from 0 to 3. But I have already taught you how to integrate it. It's a function you know how to integrate. What do you get when you integrate 2? 2x. Okay, so remember the constant, it's just the constant times x. So you can go ahead and integrate it, and then you can put in the upper bound, so 2 times 3, minus putting in the lower bound, 2 times 0. So 6 plus 1.5, so 7.5. Or if you think that looks gross, you can say 15 halves. Now, you don't have to integrate it. You could draw a flat line at 2 and go from 0 to 3 and find that area. But I don't see any particular reason. Okay, so we're going to stop there. I'm going to give you a sheet to do.